We're good. Hi. Thank you for this lovely introduction. Unfortunately, I only have 30 minutes, and I have committed way more sins than that. So let's fix this a little bit. I am going to cover about 30% here. So hi, I'm Jamie. I have been doing Python since about 2.4. Hang on, I did not realize. There we go. I've done a bunch of open source. I've done a bunch of corporate. I am currently the pursued PyBear maintainer. I was a Conch Core developer. And yes, I do have my challenge coin. And last month I got this delightful endorsement on Fedi, and I just had to include it. The keynote question from Chris is Kiwi PyCon 2022 Convention and Construction. If this sort of thing interests you, or the evolution of language, or how the language is extended to fit new uses and features, I highly recommend it. So, what are sins? Okay, the title is pithy, but they said make a pithy title. I have failed on the whirlwind part, but we'll make it work. Extending and bending Python, digging deeper into some of the features that CPython provides in order to make it your own. Some might say cursed crap. So I have done this a bunch. You might even say I specialize in it. I will not be mentioning the shitposts. I will only be talking about things that I've actually been committed and have merged. So you're sitting here. So I will say, why would you want to do this? Why do I do this? Besides that it's funny. It's annoying, and it gets odd looks from my coworkers. Quite simply, developer experience. When you're writing library code, API code, the underlying layers that define the vocabulary of your application, these kinds of techniques can help make the experience just that little bit better, just add that little bit extra. For example, this top sample is the example Django model for a person, complete with a falsehood programmers believe about names. This bottom is a hypothetical about what that would look like with markedly less sins. It's doable. None of these are required to, these are really required to make things work. But I think we can all agree that the bottom is just a little bit worse of an experience than the top. So, I won't be able to go into full detail on tutorials on how to use each of these techniques, but hopefully it's a little bit of guidance saying these are some of the stuff you might use in order to implement these kinds of things. So first up, let's discuss operator abuse. This one of the simpler ones, this is sort of ground level sin, you know. Sort of like greed in the sense of like you ate too much candy kind of sin. So Python allows you to extend many, many, many operators. Here's the list. These are the operators that are really open-ended. These are the ones you can extend pretty much like without regard. Like a bunch of the other extension points that Python has, special methods and stuff, have restrictions, and you have to like fit certain rules, otherwise stuff will either explode or yell at you. These are pretty much open, fertile ground. You can do whatever. To the point, or ordering. So back in 2005, I wrote a library called PyReg. I was a young Pythonista, and Windows back in active state and PyWin32. Well, active state is still going, but active Python was the thing back then. Registry access kind of sucked, and I'm like, I should fix this. And so I wrote a library that did this. If this sounds like pathlib, you're right. Incidentally, PyPath, which became pathlib, was about the same time. And if you remember the Py module, have you had your invasive cancer screening yet? Thank you. Thank you for the couple of chuckles. But yes, you would. It's a hierarchical store where you have keys and you can access values at the end, and it's nice and succinct and slick. And you have to use numeric division to do this. But I'm in good company. The standard library does this too. Thankfully, f-strings exist, and we don't have to do this anymore. But for a long time, this was the string format operator. And by the string format operator, I mean the remainder operator abused. You also see this in sets and dicts, where their union and intersection operators are abused bitwise operators. So, also on easy things to mess with, decorators. These are all over the standard library. You get to use them for registration, extension, transformation, or just general munging. There's a good chance you have worked with at least one of these decorators. I'm not going to go over them. You know them. If you don't know them, go check out the standard library docs. They're really useful. You should try them. I stepped it up a bunch. Back in my last job, that one, they declined to renew my contract, and I am looking for work. I was doing infrastructure with Pulumi in Python. Pulumi has this concept of a component, which is a resource made of other resources. And their API for defining them was clunky. So I fixed it. On the left, we see how it is used. It is, you would define a function, and in the body, you would say you would create all the resources that form the component, and you would decorate it with component. And that implementation takes that function and stuffs it into a type. You construct it. So yeah, that's a dynamic class. Let's discuss that. So the first thing you need to remember about Python is everything's an object. Numbers, functions, classes, the term you might have heard from outside is first-class citizens. They're not abstract names that you can only sort of interact sometimes. They're real objects, they're just variables. Which means you can, in addition to referencing them or passing them around as you may have, you can also manipulate them or build new ones without the constructs. This is a snippet from a 2011 IRC bot. It had a thing of plugins, and I was implementing ways to extend this message class. So I wrote a method that takes the class and just stacks it on top. And you're like, why do you need to do this? Can't you just substitute it? Well, this is how you do it if you want like 4 or 5 extension mixins, and you don't really know where they are at, what they are at when you're writing the code, and it depends on which plugins actually load. And so you end up with this rather interesting class inheritance tree. But it works. It works a little bit weirdly. I didn't believe this at first, but it works. So, yeah, you can just construct classes whole cloth if you need to. This is kind of dangerous. Working with classes this way, it's a little bit dangerously close to meta classes. Fortunately, meta classes are an entire keynote on themselves. So let's discuss their little brother, init subclass. Init subclass is a relatively new method. I think it's 3.6 or so, 3.6, 3.7, maybe 3.8. I think 3.6. To when you define a parent class and you subclass it, init subclass is called with the child, and you can do things with it. And this is a simple registration case where you just keep track of the list of classes for use later. You can do, like, again, registration, munging. You can add things, you can remove things, you can, look at it and be like, oh, did the user add this attribute, and then do some other things based on it? Pile of other things. It's incredibly useful. I've done a bunch of things, but I think the highlight I will point out here of Quarks. How many of you have passed quarks to a class definition? Okay, 2 of you. Because this is not a thing you see. You're probably not even aware that classes can take quarks. Classes can take quarks. This has been valid syntax since 3.0, but before init subclass you had to write a full meta class to do it, and it was a little bit weird. Init subclass makes it trivial. And so I used this when I was writing a library for a Bluetooth die, which sounds like Internet of Crap, but it kind of is. But a Bluetooth D20, RGB, LEDs, animations, the whole 9 yards, every bell and whistle you'd expect, and it communicates by messages. The computer, pass a message to the die, and the die will pass a message back. And so I wrote a Python implementation of this that had to define all the messages, including the numeric identifier used by the protocol, used in the serialization to identify what message was being passed. And so I did this with a class keyword argument. And as you can see, so at the bottom you can see usage where you subclass the message, note its numeric identifier, and the parent class, the message class, sees, oh, you defined an ID, I'm going to make note of that in a dictionary, and so that when a pile of bytes comes over the wire, it can look at the message ID and say, oh, this is message 42. Let me go find the class for message 42, and deserialization happens. I will leave the details of that as an exercise for the audience because it's a whole talk to itself. So, one last item. Property descriptors. These are ways to override the way specific properties function. And you can use dunder getAttr and dunder setAttr in order to override how attribute access works for an entire object. Property descriptors allow you to override a specific property without affecting everything else. A very simple example from the standard library would be like this. Oh, look. Remember we were discussing decorators a minute ago? And decorators can do whatever they want with functions. The @property decorator built in takes a function and returns a property descriptor instance with the dunder get and the dunder set needed for it to function. But you can also write your own descriptors from scratch. Like I did here for a dependency injector called dirge, where you would have a class and it would refer to a descriptor by name or a dependency by name, and the descriptor would take it by name and accept and go and reach out into the registry, pull it out and on request. And so you could say, hey, self.egg. I need self.egg. And you can just work with it. And it's just kind of there. So I also use this in a bound and unbound way. If you're familiar with methods on classes, you have unbound methods and you have bound methods. The bound methods have a self bundled up and you don't have to pass self to call it. This is how self magic happens. So I wrote AIO events that has a similar concept, where you have the unbound events just hanging out in the class, and then you have the bound event that is attached to a particular instance. And it is able to correctly dispatch to handlers both attached to the class and attached to a specific instance. As we see here, use a decorator for a registration purpose, and the bottom self.egged is a bound version of the event, but the decorator spam.egged is the unbound version. So I combine a descriptor with the property descriptor methods with a couple of other things here. This is like maybe a third of what I've done so far. Like this is, and frankly, this is the simple stuff. Here's the things I elected not to talk about. Because PyOhio told me I got 30 minutes. And I'm like, and I'm looking at this list going, what can I cover in 30 minutes? So that's that. So, I will warn you, one of the big gotchas is, especially because we've been discussing a lot of Pydantic and MyPy here, it is easy for these things to become untypable. I have literally written myself into corners where it's like, oh, I implemented this cool thing that's going to make my life easier. And I go to type hint it, and I go, shit. And you get to make the decision of, do you redo it so it's more typable? Do you just come up with typing work? Do you just say whatever and make some typing exceptions? You got to make some decisions there. But the important thing you should take away from this is, I might specialize this as a brand, but go and try these things. Go and dig into the Python special methods and go figure out how they work and see if you can improve some of your own code. There is an aesthetic to this. There's an art. And the best way to get good at art is to first be bad at art. So, thank you very much. That was delightfully short. So Q&A is supposed to be in the hall, but I have like over 10 minutes left. Hi, can you tell this is my first time? So I guess I can take questions if anybody has any. Okay, what questions do you have? Because I just went through a whole lot of advanced stuff, and I assume you all are wondering something. Yes?
Do you want to talk about one of the other things you didn't get?
Okay, I could do that. Okay, so do I want to talk about one of the other ones? Improv story time with Jamie. Okay. So that's the most exciting one here. So I can actually combine two of these. I wrote, you might, if you've been hanging out with me, I might have mentioned a package, GQL mod. It is a GraphQL modules. So the premise of this is that languages embedded in languages kind of suck unless you have compiler support. Thank you, JSX. The rest of us still have to work. The thought was, what if you wrote all your GraphQL queries in another file and you just imported them? They just worked as imports. So it turns out that you can, if you look up import lib and you implement a bunch of interfaces and you go and find out what sys.metapath is, you can go and define your own importers. And your importer can be like, oh, I'm going to look for GQL files. And you will look and be like, ah, yes, this is a GQL file. It has the appropriate header. It is syntactically valid. Let me go and turn this into some Python code via AST generation. So buried in that implementation is a bunch of AST templates where it generates the sort of Python code that implements those queries and then compiles that and it imports that and passes that as the module. And it is deeply magical. It is definitely going to be, if you are unfamiliar with these techniques, it is going to be a learning experience. And you might, and I'm not sure this is quite abomination level, but it's definitely unusual. But it provides a bunch of features with regards to things like schema checking NCI, schema checking at import time, and having a lot of confidence about your queries before you actually run them. So one of my many projects that, as far as I know, doesn't have any users, but I think is pretty cool. Any other questions? Otherwise, I'll keep talking.
What about weak
Okay, so the weak ref shenanigan is over in Pursued by Bear, my game engine, we have what's called sidecar data or side object data. We have data that's associated with objects. The common way to do this is to use double underscore name munging. If you're not aware, Python has a feature where if you're in a class and you prefix a name with double underscore, it'll munge that with the class name. And so you kind of get private members that way. But this doesn't work if like the list of attributes is significant for an object, or if it has slots, or a couple of other things. And so we have a sort of a variation of a weak key dictionary that will track where the keys are objects by identity, not by hash. And the value is whatever you want to associate with that object. And in order to implement this, you have to use a weak ref to the hilt. You have it uses the ID and the object IDs. It's got finalizers. It self cleans up. It does all of the things you would expect it to do. And anytime you think about you use weak refs at this level, you almost have to sit there and diagram what your references are in order to make sure you're doing it right. Yeah.
You said that the stuff can become untypable. What's your opinion of adding types to Python?
Okay, so I'm going to have a hot take here. I am not convinced of the pedantic lifestyle. I think it is. I can see its value. I can see its use. It was really obvious, a really obvious thing to exist. But at least partly, the last gig was fast API with not 5-star developers, maybe 3 or 4-star developers, and I saw fast API explode a number of times, including and the stack trace would be like 200 lines long and trace through fast API and Pydantic and maybe a few other things, and me doing Python for the better part of 20 years would sit there and go, what is this? And you would spend an hour and a half even figuring out what went wrong. And at least once, it was, why are you trying to resolve this annotation against this namespace? This is the wrong namespace. And of course, I tried to make a minimal reproduction, and I couldn't. So, and just in general, I see the value of let's make Python more strict and more predictable, but also that's just not Python. So like types are good for the developer, and they're good for the tooling, and they're good for the IDE, and they help make the APIs more legible, more comprehensible. But I'm not convinced that that strict enforcement at runtime is actually valuable and actually what's needed. If they work for your team, that's fine. If they don't, but I'm not going to say that you should use them automatically, but you should use that kind of methodology automatically by default. Anything else? Okay, thank you very much. If you want to talk about anything else, I'll be in the hall.